So 2 warm-ups, a formative quiz, all's being recorded. Then we're going to take short notes. If you notice in your note packet, there's not much left in there. Your test will be next week, Tuesday and Wednesday, all right? We'll start our review tomorrow, and I don't want to test the Monday after a long weekend. So we have a lot to do today. We're going to start off with the warm-ups. I want you to put them on. Is this mine? Or is this yours? Okay, on the back of this. So those of you at home, just find a blank sheet of paper, and this will be Edpuzzled with 4 test points. So make sure that you are listening. So the warm-ups aren't on the sheet, you guys, in class. They can't hear me when this far away from my computer anyway, because I don't have my Bluetooth on. All right, so I'm back. So the 2 warm-ups we're going to do are, and we're going to do them together, because this B group I haven't seen for a while. A group, we did one of these yesterday, but this is a super important concept. So we're nearing the end of a chapter. So the first one, we've got y equals, remember, that's always y equals, some parabola with this guy to the left of 3, and then y equals 2a, some constant to the right of 3, okay, and at 3. So we've got parabola line. It says, find the values of the constant a where the function is continuous. That's from last chapter, okay? For continuity, we just have to make sure that the parabola and the line are at the same height. So for continuity, we just go, okay, let's put a 3 in. That's it for the x. And we say 9a minus 3 equals, and what does it equal? 2a, exactly, 2a. That's it, and then we just solve it. And we'll get 7a equals 3. A would have to be 3/7 in order for, are we good at what I just did, guys? In order for it to be continuous. Now, differentiability requires one more step. For example, that function, although continuous, let's suppose that's what it looks like. Although continuous at x equals 3, because they meet up there, because I'm forcing it, this one wouldn't be differentiable. Remember, there's 3 cases, right? The sharp corner's the big one, right, Cam? Discontinuities, which I just forced a continuity, so that's not the issue. And then the other one was the vertical tangent line. The big one, though, is that sharp corner. So this chapter, you're going to have another layer added to it. It's going to say either find A and B so that the function is differentiable, or it'll say this, is f differentiable at x equals 2, justify. So just putting a yes or no gets you 0 points, because that's a 50-50 guess. So you'll either be finding missing pieces like up there, or being asked, is the function differentiable? And there's 2 pieces to that. In order to be differentiable, we have to make sure, again, we've got a parabola meeting up with a line. We have to make sure there's not a discontinuity there. So the first thing we do, Quinn, is we're going to force continuity, okay? Because if the parabola goes like this, and then the line goes like that, and then at 2, we're not differentiable. So we're going to force this piece to match up with that piece. See what I mean? And in order to do that, we do what we did up above. That's why I did that one first from last chapter. So let's go force continuity. We would say 2 squared plus 1, right, is equal to 5. That is the limit as x approaches 2 from the left of the function, correct? We're going to see, does that equal the limit as x approaches 2 from the right of the function? We're seeing if it's continuous. When I put in a 2 here, I also get 5. So far, I'm undecided, but I'm not a definite no, right? So Alex, had this been, say, at 3, I'd have 10 here, right? But at this one, I'd have 9. And there'd be a 1 unit gap. Does that make, and you're nodding, right, guys? So now I have to check, not only are they meeting, they can't meet with that sharp turn. They have to meet, like here's the parabola, and then the line takes off smoothly from there. All right? So the next thing we have to check is that the derivative from the left is equal to the derivative from the right. We have to make sure those slopes are approaching each other so that we don't have the sharp turn. Okay? So let's go up here. The derivative from the left would be power rule, right? 2x. Easy peasy. The derivative of any constant is 1. It's just making sure you're not just nodding at me. The derivative of any constant is 0. Thank you. And understand why. If the function's y equals 5 or f of x equals 5, the derivative is the slope of the tangent line, right? And on a constant function, what's the slope? 0. All right. So this is just 2x derivative from the left. And now what's the derivative from the right? 4, the slope of the line, right? We have to check if that's true at the boundary line. Is that a true statement? All right. So what that means is when I go graph these, you're going to see, and I'm going to go graph it on Desmos right now because it graphs piecewise because I want you to see what we just did. The answer is yes because I know they're meeting there and I know they're doing so smoothly. All right. So I'm going to go graph that and then you guys are going to take about 10 minutes to do the formative, and then we're going to go over it. Then we have about 10 minutes of notes. So it's just kind of bits and pieces today. But that's good because it makes the hour go fast. Those of you at home, keep on watching here. We're going to go into Desmos, and these guys are going to help me with what the functions were. So first of all, to graph these in Desmos, I put it in brackets. And I put, was it x greater than 2? What was the first boundary? Less than or equal to. So I have x less than or equal to 2, and then I put a colon, and then I put, what was the function? Thank you. X squared plus 1. Whoops. Yes, 1. So do you see how Desmos is graphing? Actually, I'm going to go put it in projector mode so it's a little darker. All right, so do you see that parabola to the left of 2, correct? And at 2. Then I put a comma, and then I put the other one, which was x greater than 2. Desmos is wonderful, right? And what was it? 4x minus 3. Now watch what should happen. 4x minus 3. That's pretty cool, right? Is it continuous? Yes. It doesn't even look like a piecewise function because that line met up perfectly with the parabola, no sharp turns. Those of you at home, they're all nodding. So make sure you understand that process with the piecewise functions. For differentiability, we force continuity and smoothness. Good. All right, the next thing up is I'm going to pause this video because they're going to take about 10 minutes to do. Actually, do you guys want to just do the formative together so my video's not so long? Are you guys okay with that? Yeah, let's just do it. Then you'll have more homework time anyway. I technically like to have you guys take those on your own, but this is such an important day that I think I want to make sure I've got a good seamless video going. So on the formative, those of you at home, you should have printed this out. I'm going to ask questions about it on the Edpuzzle. Test questions, you should get them all right because we're doing it together. All right, so first of all, this is on our last 2 sections on the product and quotient rules. Be 100% sure that you do not do what looks good. Somebody yesterday, and I'll never say a name, when I asked about the derivative of a product, said f prime times g prime. I'm like, ooh, you haven't been watching your notes at home because that's deadly, right? For the product rule, we do first d second plus second d first. That's assuming that we're taking the derivative of f of x times g of x. Right, guys? And you probably already know that, so don't need to write it. The quotient rule is when we're taking the derivative of a quotient. Equally deadly, Alex, is saying that this is equal to f prime over g prime. You'll get no points, and you'll be the first one done, and you'll think it was so easy. And it'll be anticipated. Watch, Katie. If you're one who doesn't watch your notes and doesn't do the homework when you're at home, right? Which you're not. You would go, power rule, the derivative is 3, the derivative of the bottom is 2x. Oh, so easy. That's deadly, okay? 0 points for that. We do low. It starts and ends with low, right? And I haven't been with you guys for a while, so I'm hoping you watch the notes. But it goes low, d high, minus high, d low, draw a line, square below. Exactly, it rolls off the tongue, all right? So we do low, d high. It's not difficult, but it's not what you would think it would be, right, Alex? Low d high minus high d low. We draw a line and we square below. And we do that regardless of how we're presented with information. This is the function in your face. You can actually take the derivatives. So let's go use our quotient rule. Low, d high, minus high. And what's the derivative of low, guys? What's d low? 2x. Yep, power rule. We'll draw a line. That's a dot, by the way. And we'll square what's below. We'll need to simplify it until we get an answer that's on there. So you do need to know how to simplify well. I have a 3x squared minus a 6x squared. So I'm seeing a negative 3x squared. You good with that? And then just plus 3 all over x squared plus 1 quantitatively squared. I'm not seeing that up there. It doesn't mean I made a mistake. It means I need to keep going. And where can I keep going? On the top or on the bottom? Top can be factored, right? And I see one here where they factored a 3 out, so let's try that. 3 times, and it'd be negative x squared plus 1 all over, which is the same as 1 minus x squared. So here I am at D. How would you have done on that one? Pretty good? Now, I'm going to add a question to it. It might say, and remember, here's our derivative sitting right here. You might be asked, where on the graph of this, won't have a calculator, is there a horizontal tangent line? Okay, so if I were to go graph this on Desmos and hit graph, the question is, where would there be a horizontal tangent line? What is the slope of a horizontal line? 0. We'd be looking for where the derivative is 0. A fraction can only equal 0 when the top is 0. Do you think I'm going to ask that on the Edpuzzled, guys? Because I just stressed. When the top is 0. I haven't made it yet because I need the recording on YouTube first. But so there are 2 places when I go graph that, and I think I will because the graphing is huge to be able to see it, at x equals 1 and negative 1. Now you're my first hour, and this is not a parent function, so I have no clue what the graph of that looks like. Do you guys? But I'm 100% convinced that at x equals plus or minus 1, I'm going to have a horizontal tangent line. Let's go graph it real quick. Okay, well, you guys are waiting for me to bring it up on Desmos. You go do number 2 on your own. Okay, so hop down, do number 2. And if you have time, do number 3. I'm just going to hop on Desmos and do 3x over x squared plus 1. Huh. All right, look up. Interesting graph, right? Take a look, Kaden. Horizontal tangent line at 1. Horizontal tangent line at negative 1. Alex, if I was asked at what points are they, where would I plug the 1 in? The original function. Thanks for saying that. A lot of times kids will plug it into the derivative and they'll say 1 comma 0. But points are the original function, slopes are the derivative. And then we're going to have a second derivative that tells us something too. So that's actually at the point 1 comma 3 halves, which looks good on my Desmos graph. It's good to see a visual of what you're finding, I think. So now let's go and I'll ask Sammy, for this one on the bottom, this next one, what rule did you use for number 2?
I used the approximate.
Yep, first, d second.
Yep, times second d
plus second, d first. Yep. So we'd have first, d second, which we don't know, so we call it g prime of x, plus second, and what's the derivative of cosine?
Negative sign.
Yes, it goes sine, cosine, negative sine. If you didn't hear him, he said negative sine. So that would be times negative sine x. Make sure you use parentheses if you're going to write it on the back end, or it looks like subtraction, and it is wrong. So which one do we have there? It looks like C. It's just been reversed, right? How'd we do on that one? Thumbs up. Awesome. They're doing great in here, you guys. I can't wait to get this A group all together because it's pretty cool. All right, so the next is, I feel like there wasn't a 3.
There was.
Oh, okay. I was like, wait a minute. Thank you. Thank you very much. All right, so let's go down here to number 3. Equation of the tangent line. You will be asked that all year. You always need 2 things, a point. Thank you very much. Here it is. So I'm just going to write that down. 0.014. I can actually start my equation. Y minus the y I know is equal to the slope there times x minus the x I know. The only thing that's going to change throughout the year is how you get the slope there. But it's always the derivative. Okay? So do you know how to do the derivative of a quotient? What rule? Quotient rule. Let's go do it. Low d high, what's the derivative of e to the x? E to the x. It's the easiest one in the world. Low d high minus high d low is just 1. Remember, the derivative of any linear function is the slope because the tangent line always is on the line. So it's the slope of the line. All right, so that's low d high minus high d low. I'll draw a line and I'll square below, right? And I need to find that derivative when x is what? 0. So I'm going to go take that 0 with my highlighter here. Bam, bam, bam. Hopefully it activated. And I'll go put a 0 in for all these x's because I want to find what is the derivative at this point. So it'd be 0 plus 4 is 4. What's e to the 0? 1 minus 1. So I'm seeing a 3 on the top. Am I right? And on the bottom, a 16. Now I only see 1 3/16 in here, so it's D. All right, I'm not even, when it's multiple choice, there it is. All right, second to the last one of these, then we move on to 10 minutes of notes. All right, so it's moving fast, right, Al? Number 4 is called Tabular. AP loves Tabular, especially in last year's AP exam because they were taking it at home. And there was no possible way to cheat. Everybody had a different table. They had different functions. You can't like use any sort of Wolfram or any sort of computational software because it's not helpful. The kids last year actually said it was impossible to cheat at home because even if they snapped each other, they had different, does that make sense? And it was completely timed, so you didn't have time to try to cheat. So they did a lot with tables last year on their AP test. Yours will have some. But you're taking it traditionally. So the function h is given by a quotient. So this is a tabular check of the quotient rule because it says to find the derivative at 1. So although I don't know what g and f are, so I can't go to a computer and have it do it, right? Now if this was sine x over like e to the x, there's a zillion programs out there that would do it. So you could cheat. So we're going to say my derivative anywhere on whatever that quotient is low, d high, minus high, d low. I draw a line, right? And I square b low. And then every single x will get replaced with a 1 because I'm doing it at h prime of 1. So we go to the table, right, Ryan? And it's easy. It's just, if you don't watch the notes, you're going to do g prime of 1 over f prime of 1, and you're going to think it's easy, and you'll be the first one done. The first one done on this chapter test always worries me because I feel like they do what looks good, and they feel like they aced it, and it's usually really bad. All right, so let's go do our f of 1. So let's go to f of 1 and replace this with a 4. G prime of 1, so I'm still at 1. G prime is 2 minus G of 1, 5. F prime of 1, negative 3, all over f of 1, 4 again, squared. How'd I do? Good? So I'm seeing an 8 plus 15, 23, 16ths. Okay? Now the next one is a tabular check of what rule? Product. So first I'll write it down, the derivative of r. It says find the equation of the tangent line. Ooh, that's good. Now it's tested differently. I still need a point, okay? And it's the tangent line to r. So I have my point 2, comma, the height on r at 2. And I lost my table, so will you tell me, Quinn, what r of 2 is up on the table?
What r of 2 is?
Yeah.
It would be negative 3 times 4.
Is that right?
There is no R.
There's no r.
Oh. Yeah, so it would be, thank you. So it'd be f of 2 times g of 2. Thank you. And is that what it was? Negative 3 times 4? All right. Boom. I thought r was on the table, but it's not, but you were able to work it out, right? So I'm going to start my answer. Y minus the y I know is equal to the slope there times x minus the x I know. On r, right? R is some function. I want the equation of the tangent line at 2, negative 12. I need its slope. That's its derivative. I don't do f prime times g prime unless I don't watch notes. Then I do because it looks good. I do first, d second, plus second, d first. You guys go do it. Tell me what it is. And I'm not going to put it up here because this is going to be an Edpuzzled question that I don't finish. I'll say what was the answer to part B, but I am going to make sure you guys have it. So I'm going to pause, perhaps. So I'm going to pause. That's it for the review, the 2 warm-ups and the formative quiz, right? The next thing we're going to do is wrap up those notes. So we have about 10 minutes of notes to do, and then I will stop this video. So I have to go draw those up on my computer. So take out the end of your notes. The reason it's short is because some of these were actually on. You did proofs without knowing it on your circuit yesterday. So it's going to look very familiar unless you didn't do the circuit yesterday. So I'm going to get out of this window, and I think I want to go to today's notes. You guys just got to give me a minute here because I'm not quite sure. In my first hour, that's unit 3. Why do I have those up? All right, we'll find it. Oh man, I have to go bring them up. Sorry. So, just going to make sure they're not open here somewhere else. Poor planning on my part. All right, I have to go grab my notes. Give me a minute. Sorry, Quinn. Do you forgive me? Thank you. All right, so I have to go back to unit 2. And it looks like I didn't save the notes on my notebook file. Here it is. New 2022. I apologize. I made new notes partway through, and it looks like I never saved them on a notebook, so we'll go take a look. So today we're going to work with the last of the derivatives that you need to memorize, and they're some more trig ones. So I'm just going to ask while I'm loading this. How about Sam? What's the derivative of e to the x?
E to the X.
Perfect. He said e to the x, guys at home. Maybe that'll be on the Edpuzzle. What's the derivative of ln x, Cam?
1 over x.
Perfect. He said 1 over x. Maybe I'll ask that one. I don't know. What's another good one? What's the derivative of sine? cosine, right? And what's the derivative of cosine? I'm trying to talk and work my computer at the same time. I want to insert a picture of copy of new. All right, here we go. So the ones you need to know are anything that you can use a power rule on, e to the x, ln x, sine x, cosine x. But we haven't talked about the other trig functions, and that's what we're going to talk about today. So at the very end of your notes, you'll notice there's not much. I actually think this is going to be about 5 minutes long. But it does require some memorization, but I always like you to have a backup in case you didn't memorize it. So today we're on, what's the date today? 13th, thank you guys. All right, so on the 13th, it says, recall the derivatives of sine and cosine. Remember that sine is cosine, negative sine, and we go St. Cloud, negative cloud, and it ends the way it begins. So our derivatives go this way. And if you write that down, you should never make an S-I-G-N error. A sign error with your signs. Okay, so the derivative of negative sine is negative cosine. So that gives you all of them for free. When we integrate, it's going to go up the scale. So that's going to actually give you 10 for 1. Now, in addition to those, you will have to be very familiar with the derivatives of the other 4 trig functions. So also, what's the derivative of tangent? What's the derivative of secant? Cotangent, cosecant. I think whenever I color code these, it comes off as a black blob on yours. So I think you might want to write them down at the bottom where it's white. All right, so we're going to go up here and say, well, what is the derivative of tangent? And what is the derivative of cotangent? What is the derivative of secant? And what is the derivative of cosecant? Now, if you know anybody in Calc 2 or Calc BC, I know some of you have friends in there, they would know this one and this one, all of them. Because we memorized them last year because those are on the AP test. The other 2, they'd have to think a little longer, but they'd probably think them through right, but they haven't used them as much, all right? So these 2 with the red stars, you have to know, all right? They'll be on my test, they're on the AP test. If you forget though, watch how you could get them. I'm gonna write what this is. The derivative of tangent is actually secant squared. It was on your circuit yesterday. I'm going to show you where it comes from. Notice though there's 1 T and 2 S's. Right? The derivative of secant also has 1 T and 2 S's. It's secant tangent. Do you see how they both have 1 T and 2 S's? You know what I mean by 1 T and 2 S's? Like secant, secant, tangent, secant, secant, tangent. So that's a good way to kind of memorize them. So if ever I say, what's the derivative of tangent? You should say secant squared. What's the derivative of secant? Secant tangent. But why? Okay, so we're going to do the y's of both of those. They were on your circuit. Tangent can be written as a quotient, right? And we could use the quotient rule. So this is tangent's proof. We could do low d high minus high. What's d low? What's the derivative of cosine x? Negative sine x, which would make it plus. We'll draw a line and we'll square what's below. This is actually cosine squared plus sine squared. And you should remember from pre-calc, because that's one of the basic Pythagorean trig identities. Do you guys remember what cosine squared plus sine squared is? 1. Yeah, that one pops up a lot for us. Those obscure ones you had to know from last year, they don't pop up much. But that I would commit to memory. Now, 1 over cosine is secant. 1 over cosine times 1 over cosine is secant times secant. This is secant squared. That is a proof. You probably did it on the circuit without even knowing you were proving a trig identity for derivatives. But the derivative of tangent is always secant squared. Now the proof for cotangent would be really similar. Right, Elena? But what would I write right here instead? Cosine over sine, right? But I'd still do low d high minus high d low. I'd draw a line and I would square below. So on the bottom would have been a sine squared, right? So wouldn't it make sense that if this one's secant squared, this one's probably cosecant squared? Except it would be negative. I'm not going to run through the proof, but you would end up with a negative. And it's because the derivative of cosine is negative sine. So there's the cofunctions go negative. Now, I could prove the next one, but I don't think I will because it was on your circuit and I want to give you guys a good 20 minutes to work at least. But if this one's secant tangent, doesn't it make sense that this one's probably cosecant cotangent? What do you think, Ryan? Except the cofunctions go negative. The derivative of cosine is negative sine. The derivative of cotangent is negative cosecant squared. These two, you have to commit to memory. You'll get multiple things wrong. The other two, they'll kind of go in and out. And I'll be honest, I don't usually put those other two on tests because they're not on the AP test. All right, so let's go practice with our new derivatives. I just proved that one. So let's go take a look at down here. Find the derivative. The derivative of addition or subtraction, you get to do them separately. What's the derivative of x? Done. What's the derivative of tangent? They all have one t and two s's. Secant squared. So minus secant squared x. So basically you're just adding 4 new ones with the rules you already know. Kaden, by with the rules I already know, what rule do I need to use here?
The multiplication.
Yes, it's a product of 2 functions. Hey, this is interesting. Somebody came to my Google Meet on Friday. One of the girls who showed up said, well, why don't I use the product rule when there's a constant out front? You know our constant multiple rule that says it stays put? Take the derivative of that. It's 5 cosine x, right? And she hopped on my Google Meet. She said, I get that, but why don't I use the product rule on that? And I said, well, try it. You would go first, d second, right? Plus second, but what's d first when one of them's a constant? 0. So that's kind of, she was actually in her head wanting a proof for the constant multiple rule. All right, why do I just keep it and take the derivative of the rest? Because d first is 0, so it's just first d second. Does that make sense? I thought, well, that was a clever question. I was actually pretty impressed. This one, though, one of them isn't a constant. They're both functions. Now, if that had been a 7, I just do 7 times the derivative of secant. First d second. And Quinn, you're nodding, right? Makes sense. I loved the question. It means she wasn't just writing notes down like to get a task completed. She wanted to know what she was doing. So, unfortunately, I can't remember who it was. There were 3 girls in there, and I can't remember. Was it one of you guys? No, it wasn't. All right, so first, now, what is the derivative of secant? Secant tangent. There's 2 s's and 2 t's in each of one of them cumulatively. So it'd be secant tangent, first d second plus second, whoops! And what's d first? 1. Okay? And we always factor in this class, so we'd pull out a secant x, and we'd say x tan x plus 1. So it's really not more difficult. We just have a couple more rules to use, Kim, right? So was that the end of it?
Yeah.
Ha! 4 minutes of notes. What do you think? All right, I'm going to quit. The assignment is, so those of you at home, this was Edpuzzled, so you just got a test score. So hopefully you're listening. The assignment's actually the acrostic puzzle, which I linked on the forums. So